Hi, everyone. This is the SEBA call for August 13th, 2019. Please remember that these meetings are recorded and published on YouTube, so keep that in mind. We have two topics. One is the disaggregated BNG in SEBA, and the other is ONOS 2.2 support and ONOS application branching. That's for the ONOS apps that are a part of SEBA. I think Saurav and Carmelo are going to be presenting on that first part. Carmelo, did you want to present the slides, or who should I transfer presentation rights?
Yes, you can transfer it to me.
Okay.
Can you see my screen?
Yes, we can.
Saurabh, you want to start?
Yep. Thanks. Okay, so thank you all for attending the call. We do want to talk about BNG, a disaggregated BNG in SEBA. Sometime back when I had talked about a roadmap for SEBA going forward in the second half of the year, we said that we are going to focus on two things. First of all, the transition to Volta 2.0, stabilizing Volta 2.0, including that in a SEBA distribution. That was one big topic. The other one was exploring BNG options inside the SEBA pod. Can you move to the next slide, Carmelo? And the motivation is very simple, right? The SEBA reference design that was released in March had multiple options for the BNG. The BNG could be outside the pod, and that, you know, the green dashed line is the pod boundary, and so the routers that you see on the right-hand side, they could represent the BNG as being outside the pod. The other option was the BNG could be inside the pod, in which case the top of rack switches that you see, to which all the OLTs connect, they no longer are just performing the aggregation functionality. They're no longer the AG switch. They become the ASG, or the aggregation and service gateway. So if you look at the exemplar platform, which is what we have in the SEBA release as of last month, the BNG is still very much outside the pod. So to try and reach parity with the reference design, we are starting this exploration of how can we have BNG functionality inside the SEBA pod. So we do have to thank Deutsche Telekom for inspiring some of this work. They have contributed to an FP4 based implementation of a service edge. So if you're curious, the code is all in GitHub at that particular link. Hans-Jörg has also spoken extensively, most recently at ONF Connect. There's a video for that, as well as the collateral for his talk. And so this graphic, of course, comes from their implementation of a service edge. So going forward, we circulated a preliminary design sometime back. So I will let Carmelo take it from here.
Okay, thanks, Saurabh. I don't know why I have this crazy animations going on, so I'll just disable that.
The animations were probably just in my first two slides. It should be okay if you continue from there.
I see. There? Yeah, okay. I see animations icons. I should have tried it before. Anyways, so so the plan is to disaggregate what is today the external BNG functionality in the SEBA exemplar platform, to disaggregate it as part of the SEBA exemplar. So the idea is to split the BNG box in two pieces: the BNG user plane, responsible for clearly things like packet processing, and the BNG control plane. The idea is to implement the user plane, also called the BNGU, in Fabric. So as part of the what before was called the aggregation switch, that now becomes the ASG, aggregation and service gateway, by using P4 and exploiting merchant silicon, again in the ASG, but also in the OLT. While the plan for the control plane is to implement it as an application running on top of ONOS, the same ONOS instance where today we have the Trellis applications and the other SEBA applications running. As Saurav said, we circulated a preliminary design document a few weeks ago. You can check it out, and you can provide feedbacks or add it directly to document in there. It's important to note that we understand that there are possible implementation of a disaggregated BNG inside a SEBA pod. This is one option that we decided to pursue first, and this design does not preclude other options. So let's start with the BNG user plane. As you might know, there are many requirements for the user plane. Most of these requirements are operator specific, but there are some common ones, like, for example, layer 2 access tunnel termination using double VLAN tags, termination of subscriber tunnels using protocols like PPPoE or IP over Ethernet, wholesale tunnel relay using L2TP, ACL, low-flow intercept, QoS, multicast routing, and many more. In this regards, the work that Deutsche Telekom has done has been proven useful for us to understand a fundamental thing, which is there are very few chips that can do all of these things in one pass. And if those exist, most of the times they have closed API, so they're not very suitable for our work in the SEBA exemplar. So the solution we decided to go with is that of adopting a functional distribution of all these functionalities over multiple chipsets. So this is what this distribution will look like. The idea is to use barefoot Tofino-based switch as the aggregation switch, or I should call this the ASG, and to use the Broadcom QMRAM chipset, which is already part of the OLT in the exemplar platform. So the idea is to implement things like session termination and routing, so all the blue boxes in the ASG using Tofino. And that's because it's very easy to implement all these functionalities using P4, because these functions can be easily abstracted using things like match action tables. And this is the main strength of P4, that of describing packet processing behaviors based on match action tables. And we also have the major benefit of, by using P4 to describe these functions, we get for free an API to manage the forwarding state runtime. And this API is P4 runtime. When it comes to things like QoS, hierarchical QoS, unfortunately, Tofino, like many other data center class ASICs, was not designed for QoS/buffering intensive application, but it's more designed for, again, data center class applications, so mostly throughput. That's why we decided to go instead with something like Broadcom QMRAM, which has debuffer and more advanced QoS functionality. The issue when using QMRAM for the QoS functionality is that we need to clarify which API we're going to use to manage things like queues and scheduling policies at runtime. Myself, I'm not an expert, for example, with the BAL API. So one option could be to either use existing BAL or an extension to that. At this point, the requirements of the QoS part are not very clear, so it's not clear if that API can be used or not. So this is definitely something we need to look into more. There is kind of a headache when it comes to things like accounting and lawful intercept on the downstream case, and that's because it's to properly implement these functions for the downstream case. In theory, we need to make sure we do accounting or we intercept packets after those are after the QoS part. And the reason is that we don't want to count for drop packets, or we don't want to intercept packets that, for example, we will never reach the subscriber. Now, it will be easier to implement these functionalities where we are already doing session termination. So, for example, where we're already doing the PPOE termination, that's because we are already maintaining subscriber state in the ASG. But again, these packets could be dropped along the way because of the HQS. So this is also something that we need to clarify. But at eye level, this is the functional distribution we are targeting. So having said so, this is the resulting architecture of the SEBA exemplar platform with disaggregated BNG. This looks like the existing architecture for SEBA exemplar. So let me highlight what's new in here. So first of all, we replaced the existing Tomahawk-based aggregation switch with a Tofino-based ASG switch, which runs Stratum and Fabric.P4 as the switch software stack instead of OFDPA in the SEBA exemplar today. Because we're using Stratum now, the protocol to control the switch is no longer OpenFlow, but we're using things like P4 and time for managing forwarding state, and GenMI and GenOI for configuration and operation. On top of ONOS, we have the BNGC set of applications, which is running next to Trellis and the other SEBA apps. And we also have a new API, which is yet to be defined, as I was saying before, to control the HQS part, which is implemented by the OLT. In this case, I highlighted the combination of the OLT and the ASG as our BNGU block, and that's because of this functional distribution I was describing before. Is there any question at this point before I move on? Okay, moving on. In terms of protocols, we plan to support. There are two ways of providing service delivery in broadband networks, and these are usually two, either using PPPoE or IP over Ethernet. We decided to focus initially on supporting PPPoE, and that's because it's a requirement of the SEBA design, reference design. And the issue with that is that we need to require a bit more complexity on the control plane, because we need to handle new PPP specific protocols at the control plane for things like address assignment. So for example, using the IPCP protocol, link control, authentication, and etc. The good news is that to support IP over Ethernet, which is DHCP based, and this is what we are doing in the SEBA exemplar today, we can essentially reuse the same P4 pipeline, and that's because the pipeline will be pretty much the same for the BNGU part, minus the functionality for PPPoE termination. And also we can reuse the existing SEBA applications for DHCP, authentication, and etc. So when doing PPPoE based service delivery, these are the protocols that we expect to manage. So we expect at the ASG, we expect to receive from the subscriber facing port both control and data packets. Both will be encapsulated in two VLAN tags, the S tag and the C tag, followed by the PPPoE header. For the data packets, PPP, IP, and so this is the actual data packets from the subscriber. For control plane packets that are generated by the subscriber and going to the BNGC application and vice versa, we expect to forward that using P4 runtime packet in, packet out. This is very similar to what OpenFlow packet in, packet out are. And again, the protocol we expect to support are things like PPPoED, which is used for discovery of the PPE session, as well as PPP specific protocols, the same I was mentioning before. So LCP, IPCP, and etc. We expect the ASG to be able to terminate the subscriber session for the upstream direction, meaning that we expect to have outgoing packet without the VLAN tags or PPP header, and we expect to instead aggregate this packet into subscriber session for the downstream case, so adding these headers. So to implement these functions, as I said before, we decided to use P4. Again, because it's very straightforward to do that using such language. So our plan is to extend the existing fabric.p4 program. If you're not familiar with it, fabric.p4 is a P4 implementation of the Charlie's reference underlay data plane pipeline. It's open source. It's distributed today as part of ONOS. It provides basic layer 2, layer 3 multicast and PLS segment routing capabilities as expected by Trellis, and it was designed to be a drop-in replacement to OFDPA in Trellis deployments. And that's because fabric.p4 was designed along with the corresponding ONOS driver such that we don't need any change to the segment routing applications running on top of ONOS. So what we plan to do is to extend fabric.p4 to add the BNG specific capabilities. And we want to do that by keeping the design modular. And the reason is that we already have infrastructure to control a big part of the fabric.p4 pipeline for fabric functionality. So we already have data plane and control plane support for things like routing, bridging, multicast, and segment routing. But we want to add support for the BNG specific capabilities. And we want to make sure we have the support in a way that can be independently controlled by the BNGC application running on top of ONOS. And the reason why we want the separation of concern is that greatly simplify the implementation of the control plane itself. This is one of the major benefits of P4 is that letting developers, control plane developers design the pipeline in a way that is beneficial for the control plane operation. Now, clearly there is a trade-off between modularity, designing the pipeline for the purpose of control plane operation, and ASIC resource optimization. And that's because by keeping the design completely modular, sometimes does not favor what is the allocation of things like TCAM memory and other type of memory in the ASIC to scale the number of subscribers. So we are aware of this trade-off, and this is something that we will need to explore going forward to make sure we come up with a clean design, but at the same time, we're also able to scale the number of subscribers in the pipeline. We already did some experiments implementing this BNG functionality as part of P4. And indeed, we already have an initial P4 implementation of the BNG functions, which is available at this link you can find on the slides. We also have some packet-based unit tests that show how the pipeline should be configured at runtime. So the flow rules to install to, for example, enable termination of subscriber sessions. And do things like this. This implementation, we tested it, compiling it on both Tofino and BMV2, so the software switch, and it works. But as I was saying before, we are aware that it needs a bit of refactoring to optimize the ASIC resource allocation and be able to scale the number of subscribers. The issue here is that scaling is easier when we have a target in terms of subscribers we need to support. So the question that we will need some help from the operators to answer is, what's the minimum number of subscribers that we want SEBA pod to be able to handle? In terms of functionalities provided by this initial P4 implementation, we have very basic functionality. So we have support for termination aggregation of sessions using double VLANs and PPPoE, support for things like anti-spoofing, making sure that packets received from the subscriber ports have the expected Ethernet source, PV4 source, etc. We have support for punting of control plane packets, such as PPPoE and other PPP-specific control protocols, as well as some preliminary accounting in the form of counters of per subscriber counters. There are many missing features. For those of you who have already that provided feedbacks on the design document, we are aware there are some important missing features like support for layer 2 tunnels, so layer 2 TP, as well as end-of-play scenarios where we use the 2 VLAN tags to identify the service, as well as lawful intercept and other operator-specific requirements. So these are all things that clearly we want to have implemented, but they're not yet in the initial P4 implementation. But this doesn't preclude the fact that we will be able to add this in the future. So moving on, talking now more about the control plane. As I said, we expect the BNG control plane to be running as an application on top of ONOX next to the other Trellis application as well as SEBA applications. We are aware of the fact that probably coming up with a BNGC implementation represents 90% of the complexity and the work, and that's a known fact when developing networking applications, where the data plane code is usually, the control plane code is usually at least 2 or 3 orders magnitude larger than the data plane one. As a starting point, we want to be able to handle the basic things, so authentication and configuration of subscriber session using PPPP. And we decided to allow the implementation of the control plane in a way that, allows independent evolution of the control plane apps as well as the pipeline. So we decided to come up with a new ONOS API called the BNG Programmable API. If you're familiar with the ONOS architecture, this is what in ONOS we call a driver behavior. So the BNG Programmable API is essentially a Jive API. It's a pipeline agnostic Jive API that allows the BNGC application to modify the forwarding state of the BNGU pipeline, as well as setting the QS parameters, read counters, etc. And again, the purpose of this API is that of enabling independent evolution of the P4 pipeline and BNGC application. So once we agree on this API, we can have 2 different teams working on the user plane and the control plane. So what is missing at this point from our design document is a specification of the QS requirements. And as I was saying before, also the API that will need to manage a runtime, the QS part. So this is where we probably need help from the community in coming up with such requirements. Saurabh, do you want to talk about the demo plans?
Sure. So we have 2 big events coming up in the next couple of months. The first one, as you know, is ONF Connect next month, I believe the 2nd week of September. And then following that, in the 2nd or 3rd week of October, that is the Broadband World Forum in Amsterdam. So first, let's talk about ONF Connect. The idea over here is that, to be able to demonstrate SEBA, there's actually 2 demonstrations of SEBA. The first one is what we have released as of July, as of last month, which is the SEBA 2.0 alpha release, and that will still have the the aggregation switch with the external BNG, and the aggregation switch will be pure L2 functionality going from the OLT to the BNG and back. So that's one demo. The other demo will be this one, which is the first demo of SEBA with Stratum and P4 switch with embedded BNG functionality, as Carmelo was describing. The focus over here really will be on the BNG user plane, the part of the BNG user plane that's implemented in the P4 switch, and of course it'll have the main functionality, which is the PPPoE session termination, as well as accounting related to that, and the anti-spoofing part. So of course, so this is only 4 weeks away. So the BNGC implementation will be very simple. We actually won't have the PPP protocols implemented, but a lot of it will be done using static session configuration and manually triggered. Okay, but the idea in BBWF is that we would be able to build on this particular demo, hopefully with a more advanced BNG control application running on ONOS, and possibly some integration with NEM, and at that time BAL 3.1 as well. And if we can get the hierarchical QoS, that'll be even better. BAL 3.1, as far as I understand, does have the capabilities of doing 3 levels of hierarchical QoS in the command chip. So we do invite ONF members and collaborators to join us at the ONF booth in BBWF. And I'll hand over to Asim right now to talk about our plans for the ONF booth there.
Right, thanks, Saurav. So this time we have kind of upped our game at BBWF. For folks who don't know, we used to have about a 16-18 square meter booth last year and the previous year. This time we have opted for a bigger booth, given the popularity and the amount of interest in ONF, and especially now with SEBA going kind of mainstream, and we are doing this acceleration of SEBA. So right now we have a 24 square meter booth. It's right in a prime real estate with the 3 sides open. The booth number is C40 if anyone is interested. But all of that means that we have taken on more costs. The total costs, including booth kind of rental, booth build out, graphics, shipping, all of that would be between $35,000 and $40,000 for ONF. And so hence we are inviting everyone who is interested in participating and promoting their SEBA-based solutions and their involvement in SEBA to help us sponsor and co-sponsor this. So we are thinking that ONF plus 4 more co-sponsors, so about 5 people, adding up to about $7,500 per person to $8,000, right? So that's the range. We are looking at $7,500 per sponsor, and obviously those sponsors would be invited to not only add their hardware into the pods and talk about the hardware, but also showcase any commercial solutions they have leveraging the open core. The idea is not to show anything which is non-SEBA based, obviously in the ONF booth, but anything which is related to SEBA and leverages SEBA, open source, and open core. That is what we expect the sponsors to show and promote at the booth. So this will go out to all the partner companies for sure, and some member companies. But for the people who are on this call, if you think this is interesting for your organizations to highlight at BBWF, please let your management and kind of know that this is something they should be expecting, and your support for it, so that we can get that done as soon as possible. I'm expecting to send this out within the next 10 days to all the member companies who are involved in SEBA. Any questions?
Okay, thanks, Asim. Yeah, thank you, Asim. As you can see, our work is cut out for the BBWF demo. We do have some plans for the community, specifically launching a BNG brigade either this week or next, depending on how many people express interest, and we can find a common time for everyone to meet. We do have some interest from Infosys and Sterlite to join the BNG effort, the disaggregation of the BNG effort, possibly Tech Mahindra. If you are interested, if you're on the call, you're hearing this, or you're watching the video, please do reach out to Carmelo. You can also reach out to me. The primary tasks of the BNG brigade right now will be literally implementing the BNG control plane, and then optionally having to integrate with the other parts of SEBA or improve and add features and optimize the BNG user plane. Okay.
I had one last highlight about reminding that we have a preliminary design document, and for everyone that wants to provide feedback, you're very welcome to do so.
Any questions?
Does the BNG work depend on, I guess, the new ONOS, the containerized, disaggregated ONOS?
It does not depend on what we call micro ONOS, which is the disaggregated containerized ONOS, but it depends on a newer version of classic ONOS. So we're moving from ONOS 1.13, which is currently used in SEBA 2.0, I believe, to ONOS 2.2. I think Theo will talk about this later. But yeah, it's not using the containerized, what we call micro ONOS, but it's used a new version of classic ONOS.
Okay. Thank you.
I think this will also enable us to use the Tofino switches with SEBA, right? So with or without the BNG functionality, we can integrate, we can replace the OFDPA with the Tofino.
Yeah, that's actually correct. The aggregation switch in current SEBA has very minimal functionality of just L2 functionality of transporting Ethernet frames across from the OLT to the BNG, to the external BNG. That functionality is already there in the fabric.p4 pipeline for a Tofino switch. We weren't kind of highlighting it because what we really wanted to do was bring in the new functionality that Carmelo talked about in this presentation, but you're absolutely right, Sarkanth. Both things are possible with the Tofino.
Okay, that's great. So can we try out now, or we should wait a little bit more?
Carmelo?
Yeah, so I think what's missing, right? So we already have pipeline support for VLAN cross connect, which is, Sarah was saying, the only requirement for the aggregation switch at this point, as well as basic routing. That is there. What is missing? It's the ability of SEBA of using ONOS 2.2, which is required to use P4 runtime and Stratum. We have already ported the SEBA applications to work with ONOS 2.2, but I don't think those have been merged yet. So probably it's a matter of days. Probably next week we should have a set of SEBA applications that will allow you to use the latest version of ONOS and use a P4 switch with SEBA with just cross connect.
Okay, thanks, Carlo.
Yeah, part of the different applications, there is also a change that is required in the public cross-connect service in NEM, because the corresponding API in ONOS has changed between 1.13 and 2.2.
So that is also required to make cross-connect work, right?
And what's the plans ONOS in next several?
I'm sorry, Mahir, you were breaking up. Are you asking what the plans for ONOS are? I think Teo's talk next is going to cover that.
Yes, sort of. The next ONOS release that will be used in the SEBA, and I mean next SEBA release.
Yeah, I think Teo will talk about that next. So I'll defer to answering that question.
Okay.
If anyone has more questions on this particular presentation, let's talk about that before Teo starts off. Okay, Teo, would you like to talk about ONOS?
Yeah, I can talk about ONOS. I prepared mostly to talk about the ONOS application, but to answer your question, I will say that the plan for the next SEBA release is definitely to move to ONOS 2.2. Actually, we already tested that ONOS using the current SEBA setup, so with an OpenFlow switch, and everything is working. So we'll probably do the switch for SEBA master to the newer ONOS as soon as we release the applications. Can you give me presenter right, Saurabh?
I made you one.
Okay. Okay, so I hope everyone can see my slides. But basically, in order to migrate ONOS to version 2.2 in SEBA without disrupting what is happening with Vault 2.0, we need to branch the application. We'll need to do that because the newer ONOS requires Java 11 to be built. So very simple, what we are proposing is to branch, to create a 113.x support branch for the ONOS apps, starting from when we tagged them for SEBA 2.0, and move master to be built on Java 11, bumping the major version in the application. This will mean that whoever is still working on the 113.9 compatible application and creating bug fixes and new features in there will have to cherry pick those changes in master. Since a picture is worth 1,000 words, this is what we have now. We tagged the application for SEBA 2.0 alpha a month ago, and we're going to start a support branch from there. We need to update the Git review file in order that every patch created on that branch will be pushed to the right destination. We are going to bump the major version for the application. So for example, the OLT application will move from 3.1 to 4.0. And then we'll just need to make sure during the review process that everything that goes on the support branch will be cherry picked on the master branch. Is there any question or any opposition to this?
How long do you think this is going to continue, or do we think that say Volta 2.x is going to end up switching to the newer ONOS? Is there a? I guess that's more of a question for the community.
Yeah. So my personal standpoint is that ideally, as soon as Volta 2.0 reach some kind of stability, have exactly the same features. So ideally, should to change anything in that environment for now.
Are we looking to bug
this
fix?
is my.
Sorry.
Oh, go ahead, David.
Are we gonna cherry pick the other way for bug fixes as well, or is this just a one-way cherry pick?
On both branches.
Okay. You
Of
said
course,
there was
that assume that the bug will fix it.
Yeah, yeah. You said the instigation for this was a Java 11 requirement. Could you expand on that?
Yeah. ONOS 2.2, we need to build them using Java 11. To build them for ONOS 1.13, we need Java 9, if I'm correct.
Java 8.
So we just need to tell Jenkins which branch needs to be built against which Java version.
So I can't build an app against Java 8 and have it run in a Java 11 environment.
Well, it's two things. It's not just the language version. With ONOS 2.2, we changed the way applications are defined in terms of OSGI type of annotations. So there is a slight difference in how applications are defined in 1.13 and from ONOS 2.0. So that's why we need two different branches.
Yeah.
Right. So it's probably more about that than the Java version, I would think, but maybe not.
Yeah. So yeah, of course there are differences between the applications, so that's another reason for branches. This particular branching scheme is something that we figure will play nicely with Jenkins to make our life a little easier. But the main reason to have two branches is that it's not only a Java version difference, but it's also differences in the code.
Is 1.13, that's not an LTS branch of ONOS, is it?
I don't think so.
It is not. It is not. 112 is, and then I believe the next LTS is supposed to be 2.2.
Okay. Is there a end of life target for 1.13?
That is a question for the ONOS team. I'm not sure, actually.
Okay.
So if no one is against this process, in the next few days, I'm going ahead and create the branches and prepare the Jenkins build. Does that sound good? I'll take that as a yes.
Great, thanks, Theo. Any other questions on our plans for ONOS and also the BNG work that you heard about today? Okay, thank you. Zach?
All right, thanks everyone. That's it for the for the SEBA meeting for today. If there are any other things people want to put on the agenda for next week, either let me know or add it to the call agenda. Thank you all.
Thanks, bye.
Bye.
Thanks.
Thank you. Bye.
Thank you,
Bye, guys.